A very warm welcome to the judges. We are Team 10, Rover Deployment Services, and tackling the flagship challenge, we will safely place Asagumo on the moon. We are a multidisciplinary team of scientists and engineers hugely interested in space technology. With experience in 3D modeling, planetary science, asteroid mining, and spacecraft systems, we use unique and creative solutions to get to the heart of any problem, validated by an approach that questions everything and anything. This is the agenda for today's presentation, beginning with the technical constraints.
Before we started designing, we considered many constraints. The temperature extremes, the powdery lunar regolith, and the potentially uneven surface meant that it was necessary to minimize mechanical parts and forgo the use of an underlying platform or cushion mechanism. We also considered the shaking that would be experienced during launch and the mass, power, and size requirements, and therefore our system is designed to be very secure and well below the limits for mass, power, and size. Our solution combines the innovation of NASA's Sky Crane and the reliability and simplicity of the locks and spreaders used on shipping containers. There are three main parts to the solution: the winch, tethers, and clamp.
We worked through various ideas and decided that we wanted to control the descent of the robot. The lightest design consisted of a nylon-supported pulley system controlled by a stepper motor activated by the lander, which lowers the payload to the surface. Nylon was chosen as it can withstand the lunar day's range of temperatures, and the stepper motor is more than capable of maintaining the values that you can see on the screen. The two nylon load-bearing tethers will split and attach to all four corners of the lowering structure for stability purposes. One motor attached to the driving axle will rotate to lower the system. In a future design, we could have two motors rotating independently to allow more maneuverability to retrieve Asagumo from an uneven surface. The communication wire in the middle, with slack to ensure that it is not load-bearing, is necessary to deliver the signal to actuate the mechanism explained next by Tom and Gorak.
We developed a mechanism inspired by the lock-and key system used to carry shipping containers with large cranes. Our solution incorporates a spreader bar with two stepper motors rotating the bar-shaped key once Asagumo reaches the ground. The spreader bar is then raised, and Asagumo continues on its journey. The spreader bar distributes the load and allows simple tethering back to the winch at the top of the deployment box through mounts at its four corners. The advantage of having separate mechanisms for lowering and fastening is that the tethers will never twist and Asagumo remains stable.
The bar and key shaft are thick enough to support Asagumo, and the lock mechanism is strong enough that it would keep it secure during the shaking of the launch. Another advantage of this design is that the system can pick Asagumo back up with just the simple addition of weak magnets to locate the key to the lock.
Our deployment system is significantly low cost, low power, and low mass. It fits well within the size and mass constraints as seen in this table. Components from the deployment system are easy to operate, easily available off the shelf, and significantly cheaper than developing from scratch. The simplicity of our deployment system makes it highly feasible, given that all the technology has been tested. Ultimately, reusability and retrieval of Asagumo were identified as the key design drivers for further improvement.
This would allow for reduced development costs and allow Asagumo to be recovered for future sample or robot analysis studies, which would enhance the scientific and economic growth of Spacebit. In summary, our deployment system is lightweight, low power, and cost efficient, and its simplicity reduces the risk of failure. We hope you could support us in winning the flagship challenge, and we are extremely keen on collaboration opportunities with Spacebit to develop novel technologies in the future. Thank you.